of supremacy. And moving ahead, ladies and gentlemen, we have the other keynote presentation on swapping ecosystem safety and standardization, which will be delivered by Mr. Abhay Patwardhan, the director of Chheda Electricals. Ladies and gentlemen, Mr. Patwardhan has a vast experience of more than 18 years in electric vehicle domain. He is post-graduated from IIT Mumbai in 1995. He is part of most first attempts in India in EV technology. He was heading Mahindra, the first EV of India, first EV export from India. He was part of the team who made first fast charge station in India. He was principal architect for the first electric bus of India, which was inaugurated by our Prime Minister Shri Narendra Modi ji in the Parliament. Since June 2018, he is working as the director and co-founder of electric vehicle startup, that is Power Swap, promoted by Chheda Electricals and Electronics Private Limited. Please put your hands together in welcoming the director Chheda Electricals, Mr. Abhay Patwardhan.
Yeah, I think the preemption for this typical subject has already happened in since morning, right? Since morning we have been talking of figuring out an elephant. There has been a lot of sessions which typically talked about right from the viability, costing aspects of it and many things. So this typical presentation will try to drive it more on the technology side, okay, so that we try to find some solutions to the problems, okay, rather than seeing that, yeah, we are just as we said that we are just at the start of the marathon. So there will be only problems at this point of time. So let's try to find out some solutions to all this. And then I think Shubhendu Sinha also mentioned two things in his presentation. Is the challenges of standardization happens at two different levels which he talked about. And one is about the connector and one is about the communication of it. And that has been a lot of diversity of views. The reasons could be anything. But unless and until there is a consensus of these two things, any forward standardization would be very difficult. And obviously, for the sustainability of the entire ecosystem, interoperability is must. And then it means the standardization has to happen. That's what I'm trying to just put in. So just going forward, can you just help me with this one? Yeah. So, so with the cognizance that this is a presentation just before the lunchtime, I'll try to make it as, what you say is better to hear and as quick as possible, okay? But so just an overview of Chheda Group, we will have in a couple of slides and then mostly deep dive into what best can be done in the present circumstances. So at least we start one step towards standardization. That's the only intent of this. So this is, we are a startup, we call ourselves a Power Swap R&D. Is a startup promoted by Chheda Electricals, working in this field since 2018. Okay, and our first swap station has been demonstrated in Auto Expo 2020, a full-fledged with all the automation and everything. And then we realized that I think we need to work again. And till today we are working on the swap station viability, ecosystem and all. So that is the kind of subject it is, and we are trying to take it in a right way. So these are various customers, many of them are here, and all of them over here we would like to be on this list as well. So yeah, so this slide is like we all know what it is, right? And with all these things, in India, typically by its virtue of its typical socio-economic conditions, one thing is loud and clear. It is very difficult for electric energy to reach the vehicle safely. The only way for sustainability is getting the vehicle to the safe energy. Okay. So with these things, what we think of is as a Power Swap R&D, we had our charter. As the name says, we have a strong belief in power swapping. or energy swapping. So we should work on, one is LFP preferred chemistry. This has got typical an aspect of the climatic conditions and the usage abuses typically in our ecosystem. And then a thermally stable cell, we thought of pouch, and there are reasons for that. So we think of, and pouch handling is a technology. So we thought of putting our efforts on those directions. And then a battery swapping is the most prominent refueling systems which will probably unfold in future. That was another belief. This has been our product range. We have got a lot of products on vehicle, and eventually we have got a lot of products outside vehicle also. So our first thing is the battery packs, the BMS, because when we talked about battery swap as the thing which is going to be forward, then the BMS had to adapt itself to that ecosystem. For example, BMS has to be fully diagnosable, it has to be fully communicative, it has to be fully connected to the IoT, the complete diagnostics has to run, the prognostic has to run, and then more important is it should also spit out, or it should also throw out the objective information about the state of the battery at that particular, in that particular lifespan, right? So many of those solutions, then we have got a complete IoT ecosystem being developed. So as a power swap R&D, we believe in one thing, is we are a product company. We are kind of we support from the back end of it. So everything what we develop over here is a product. So BMS is a product, though we use the same product, we also offer it as a product. Similarly, the battery swap ecosystem is a product. So we use it ourselves, and we say that ours is the use case condition where the end-to-end hygienic safe swapping is possible, and it still can be used by anybody else. Yeah. So this is typically a battery swap ecosystem. As we see, there are three typical pillars of it. OEM is assumed to be encompassing or a kind of battery, that's a different play. But it's a battery OEM who basically will give the container or energy container. If somebody who is managing the complete slots of that ecosystem, and somebody making the business out of these batteries and this slot management. So these three are typically three vertically independent entities, and all the solution which we have got around is basically harnessing all these three entities with their independent existence. So that has been there. So this is something which is few about the power swap R&D, and I think, so see, looking at, okay, so with all the sessions in the morning, right, one thing is loud and clear, that the standardization has to happen, okay? Because if you want, one has to exploit the infrastructure to the fullest capability, one has to put all the business cases around it. The standardization is must, so that the numbers can be increased. So when we look at standardization, right, we talk of two things. One is, like for battery swapping, there are two major constraints. One is the power connection management. Typically the in-out cycles are very high, and then one of the safety prone sensitivity lies around the power connection management. And then the charge process safety. Typically most of these battery hazards, they originated from the typically a charging exercise rather than the drive. That has been the observation. So for sustainability at mass level, vehicle energy refueling, this is prominent statement which we always talk of, okay, is should not depend on user infrastructure, because the quality of user infrastructure in India is a pretty big. So when I say anything about standardization over here, majorly the focus has been two-wheelers and three-wheelers. Four-wheelers or the big battery packs, the standardization would be a different ball game. That's something which I am not talking of, okay. So for sustainability at mass level, the vehicle energy refueling, it should not depend on the user infrastructure, because no guarantee today about the infrastructure quality in India, okay. So there are a lot of people don't have even parking places. A lot of people, they take the energy which they don't know of. Running the lines from the meters to the parking lots is difficult. Typically in Bombay, the meters are on the floor. In Pune, the meters are on the ground floor. So there is a difference. So even Nexon users are finding it difficult in Bombay to charge the vehicles. So dependency, and typically when we are talking about, see one point is very simple. Today whatever numbers we are talking about are very minuscule. So any inference out of these numbers may not be the right way for the future. When we even talk of penetration, which is say 20% of the today's IC engine vehicles, the complete problem statements could be different. And that's point which has. So then about the public infrastructure, it cannot engage the infrastructure for a long time. So what means is the charging at place is impossible, or charging the vehicle maybe at home or at public infrastructure probably will not be, will have find the limitations in the future as the number increases. So what is the way? Probably the swapping is the only way where the safety can be achieved. So what it means is battery swapping is the most prominent way. So that goes unsaid. What it means is battery ownership is more or less away from the OEM. Okay, it is a very similar emulation of the fuel and the vehicle separate. Today the fueling system is separate, the vehicle system is separate, and both are actually complementing each other. A very similar model has to happen or has to come in the battery swapping area as well, or for that reason, even for the complete sustenance of two-wheeler at the numbers at which we are talking of. Okay, so means battery ownership away, what it means is for the things, battery, ultimately battery will happen as a service, because once you detach it from the vehicle, then it becomes a floating asset, and there will be a lot of different business cases would be weaved around the battery itself. So battery, battery becomes a kind of service, and then what it means is basically it needs an interoperability, right? The interoperability is needed because as we talked about the infrastructure cost, that was one of the point which was talked about, and how to amortize that or how to cover for that. So the only way is use common. And to do that only way is try to standardize as much as possible, okay, or to have interoperable. Now these typical aspects are away from any numbers of business or something. I'm core R&D person, so I'm not going into those details, but I'm trying to be more onto the feasibility centricity of it from the implementation perspective. Once we talk of battery as a service, it means there will be some business around the battery in the future, which we can't define today. It will unfold as the market demands. But one thing is sure, that there needs to be a certainty of the worth of the battery at any point of time. So there should be some mechanism in the standardization which also allows to throw out a number which could be a conservative one, or but that would indicate at least the guaranteed state of the battery. Okay, because everybody has got their own algorithms. Everybody has got SOH algorithms, and SOH algorithm is a PhD topic. It cannot be assessed objectively. So there has to be some objective methodology where this number can be used for the any business kind of impacts or those kind of things, for insurance, for second sale of the vehicles, and many things, right? So those kind. And we really don't know today what will unfold in the future. So the infrastructure should be ready today by way of standardization, and the business cases can explode around that in the future. There should not be a limitation to that. So what it means is a need of standardization all across the process. Now few facts, right, which we can't ignore. Commonization of connector is highly unlikely. Nobody is going to accept it, be it OEM, be it battery manufacturers. Everybody will have their own constraints, own preferences. And so let's accept it as a fact. That will not happen in the future, right? But secondly, the battery safety during swapping process. This is much more important, because battery swapping, when we talk of battery swapping, we typically talk of multiple insertion cycles. It means there is a degradation of contact. It means some measure has to come in to ensure that the degradation of contact is not beyond certain level, otherwise it has to be replaced. So those strategies have to come in place. Then we talk of battery safety during charging. So the complete charging process has to be guided. As Piyush said, it is simple. IEC 61851 mandates that it is the battery which demands and the charger which follows. A very similar philosophy, I think we have to adopt that, and and then all these things should happen very clearly on minimum mandation, okay, that don't infringe into the product spec. This is a very thin line. Many times the policymakers go overboard. Similar things happen in AIS 138 as well. And somewhere has to say, no, we should only mandate what is hygienically needed, what is safety-wise needed, only the mandations, but not the product guidelines. So that is very important aspect of the standardization as well. Okay. So standardization ultimately is a balanced act, and yeah. So a few more details. So see, charging of swap battery, is it the same phenomena as if a vehicle is charging from a public infrastructure? There is a DC power source which is outside the vehicle, and then there is a vehicle which basically communicates with the DC power source and then gets charged from something which is completely outside the vehicle purview. And battery swapping is, especially the charging process in the battery swapping is no different. Okay. So, and there is a classical guideline, IC 61851 lays down the complete guidelines, which is also AIS 138, about these systems. So I think there is no need to invent something very new or different for this. Take it as a baseline and just try to adapt it to or tweak it appropriately to what the use case which we are talking about. So that is something which we can do. So 61851 today only talks about this thing, okay? It talks about the communication, and it talks about the hardware interface between the vehicle and the charging station. So similarly, we should only define the connector requirements and the the software interface between the battery and the charging station. And then I think once that is done, then there could be a lot of interoperability avenues can unfold. That's what we see, okay? So what it means is this. See, if you look at 61851, it's a very, it's a Bible for, I always call it as a Bible for the charging system, 61851. You go through all those 1 to 24, it just covers everything, including safety, including mandations about the, all the use cases now have been captured. So well-matured process, been accepted from Europe and IC, and then we also have aligned to that. So I think that we should use as a baseline. That has got a classical structure of communication, right? From the vehicle is or battery is not connected to something happens as long as moment the battery is connected, to a compatibility assessment between the charger and the battery, to the complete energy transfer during the process, and also the exit sequences which typically happen as a normal exit or an exit as a fault exit as well. So I think this is already there. So it's question of looking at the appropriateness of clause by clause or all this and trying to tweak it to best way to the battery swapping system. So I thought of going one level down. Okay, let's see how it unfolds. So if you look at AIS 138 or 61851, it has got three systems. Typically, it's system A, which is a CHAdeMO. System B is GB by T, has been taken from GB by T. And the system C is typically CCS2 combo, what we normally work on. So we should just put this matrix, right? Then system A, the communication is over CAN. Then in vehicle is also, hardware requirement is also CAN. The vehicle inlet interface is digital, it's completely. And then the level of protocol definition is the maximum, is the most granular level. The complete protocol matrix has been given. And that matrix, if you look at along with their hardware interface, it classically encompasses all the use cases which normally will unfold in the real life. So that has already been done in that. System B is again over CAN. Here the compatibility is over type 2 kind of interface where there is a proximity pilot and that you actually read. But then there is some haziness about the protocol because they allow the protocol to be defined by the users, okay, or that's actually not been defined to the message level, okay. And then CCS2 is typically over the power line communication, in vehicle there has to be a CAN at the back end, but at the same time modulation, RF modulators for power line communication. So that's something which cannot be adopted to the two-wheeler kind of infrastructure. So, but again, the vehicle interface is over type 2, and then it's a multi-layer, multi-protocol. So if you look at this matrix, probably the most adapting thing would be just pick and choose something from here, pick and choose something from here, and see if we can conceive a standard around it, which will basically work for the as a standard for the interoperability and all. So that's it. Yeah, sorry. So connector lookout, like again, there is no mandation on any product over here. So connectors, one can use any connector. One can use inline connectors, one can use the base mounted connectors or the wall mounted connectors, anything. But what it should be probably, this is something suggestion, right? Okay, and I think we can dwell on this. The intent of this presentation is trigger a start point where it can be reached. Okay, so let's, so that is the, so maybe a simple type 2 interface I had shown over here. So a very similar interface can can be there in the connector. Connector mandations is very simple. It should have CAN H CAN L, and it should have some pilot function which is actually normally can be there in the type 2. So very similar function can be used, and with these things, right, the typical interoperability can be achieved using a different chord set. So the actual deployment of it will be, it will explore as the business case comes in. Okay, so if at one place like there is a lot of business for certain type of vehicles, the people can have their own chord sets and charge the other batteries as well. So it doesn't mandate onto the actual product as such. And then a communication outlook is another second aspect which we talked of. So if you, that also we tried to analyze. Okay, so that is a DC1 to DC5, that is the classical phases which have been outlined in 61851, which starts from the connector connection to the compatibility assessment between the chargers. The charger publishes its own capability in terms of voltage current, battery publishes its own capability about the voltage and current, and then the BMS, here in case we talk BMS. So that basically we decides with this charger what is the charging rate, because it understands its own safety and all. So the complete protocols can be implemented on BMS. Now this protocol, see already this message structure is available. So we need to tweak, align, or drop few idea things which are vehicle centric, or change those to have more safety. So that's some deliberation I think we need to, one can have. But these two things as basically can be picked up directly from IEC 61851, which is non-debatable, universally acceptable solution which has already happened in four-wheelers, and try to push it to the for the swapping solutions. Okay, and yeah, and I think this is the this can happen only through collaboration, as it has been talked earlier, right? That we, I think we have to be opened out, and we should exchange the ideas and all, come together and give a very concise view to the policy makers about what to standardize and to what level. Yeah. So thanks for this, patiently listening to this, especially at this point of time where we are just waiting for the lunch.